Hello, I'm Marcus Lake and welcome to episode 6 in our GeoChem tutorial series. In this episode we'll be discussing testing directly onto samples or choosing the correct sample containers for your XRF program. As you can see, I'm joined by my esteemed colleague Todd Prolene. Todd, how you doing, mate?
I'm okay, mate. How are you?
I'm okay, Todd. So where do you want to start our discussion today?
I want to start our discussion with the nose of the analyzer. Two things I want to point out. The active area of measurement on our instruments is about a circular oval shape about 9 millimeters wide. So whatever you place in front of that area will be measured. The second thing I want to point out is that we have various VANTA models, and those models have different windows, and those windows have different thicknesses, and so that will have an impact on the model that you choose to purchase.
But I thought today's discussion was about our sample containers.
It is, but the concept we need to get across before we start talking about sample containers is that whatever is between the detector and the tube inside here and the sample will affect the performance of the instrument and attenuate X-rays.
So what you're saying, the thickness and the density of that window is very important to your XRF analysis.
It is. It directly affects the performance and how low you can measure generally.
So the top of the line analyzers that we use have got better capabilities because of the size of that window.
Exactly, and the area of the detector. So we tend to align thinner windows with larger area detectors so we can maximise performance.
When we build our XRFs here in Boston, we test and calibrate them under optimum conditions.
Optimum conditions means as a fine powder, usually less than 150 or 250 microns, in a sample cup with a thin Prolene film. That's standard practice.
To achieve the best results possible, our samples are homogeneous and we put them under conditions to ensure minimal distance between the material and the detector.
It's also very important for elements, titanium and lighter. It's these elements that are more easily absorbed by anything between the sample and the detector.
So Todd, should we check some samples?
Let's do that.
Testing in sample cups can be great. However, there are time and labour costs associated with buying the cups, cleaning the cups and making them.
So why would you test in cups? Well, if you're doing full sample prep, if you want the best quality data possible, and if light elements are very important.
Now let's put it into a plastic bag.
Okay, lots of our customers test samples in a plastic bag. So what's the impact of the plastic on the results? Let's have a look and test the same sample through one layer of plastic.
Now let's put this into a pulp bag.
A lot of our customers, when they get their samples back from the lab as pulps, they want to do a quick test. Let's have a look at the implication of this paper on the quality of data.
So here's our paper. Here's in the plastic bag. And here's straight onto the sample cup. Now should we have a look at that in an Excel spreadsheet, Todd?
Let's do it.
So Todd, tell me something about this data.
Okay, when we plot up all the readings we took, the first thing I notice is we're reading quite close through cups to the true CRM value, but maybe we could have tested for a little bit longer because we only did quite short tests.
Yeah, we only did a 20-second test time on each medium, Todd.
The other thing I see quite quickly is the impact of plastic bags, particularly on the light elements. Huge impact, and that's the big reason why I like to do this exercise, because I don't think people appreciate just how affected those light elements are by plastic.
And also see this aluminium, it doesn't drop off significantly from bags to paper. Why is that, Todd?
I think there's some aluminium in the paper bag itself.
So I know some of our customers are taking that the chemistry of the bags and subtracting it from their final data sets.
Yeah, and the way to do that is to just put a blank underneath whatever film plastic, paper you're using to understand what chemistry is in the container.
That sounds like good practice, Todd.
Good practice.
So, Todd, how will you summarise our findings here?
Sample containers are influencing your data, so it's important that you understand the extent of that influence.
And sample prep's very important as well.
Exactly. That's why we're going to cover that in the next video.
Thank you for joining us in this video. We'll see you in the next one. Thank you, Todd.
Thank you, mate. Safe travels. For more detailed information on this topic, please take a look at this independently published paper in the journal Geochemistry, Exploration Environment Analysis. Note that there's a fee payable to the Geological Society to download it.